But before we get to the sunlight, before we get to Feynman's revelation, we need to start with something that should bother you. A question so simple, most people never think to ask it. Wood is made of carbon. The air around it is full of oxygen. Carbon and oxygen love each other. When they combine, they release enormous amounts of energy. That's what burning is carbon meeting oxygen. So here's the question. Why doesn't wood just burst into flames? Right now, it's surrounded by oxygen. The oxygen is right there, exposed to it every second of every day. A fallen tree can sit in a forest for 100 years. Carbon, surrounded by oxygen, and nothing happens. Why not? Because there's a wall in the way. Feynman described it like this. Imagine a ball sitting in a little valley on top of a hill. On the other side of the hill, there's a deep hole like a volcano crater. If the ball could get over the ridge, it would fall into that crater and release tremendous energy. But it can't. It's stuck in the valley. It needs a push. That push is heat. Specifically about 250 degrees Celsius. That's the ignition temperature of wood. Below that, nothing happens. Carbon and oxygen sit next to each other like strangers on a train, inches apart, for centuries. But here's what's actually happening at the atomic level, and this is where Feynman gets excited. All atoms are in constant motion. Feynman called it jiggly motion. Everything is jiggling. Your desk, your hand, the air, every atom vibrating, bouncing, colliding millions of times per second. At room temperature, those jiggles are gentle. The carbon atoms in wood bump into oxygen molecules constantly, millions of collisions every second, but none of them hit hard enough to get over the barrier. Not enough energy. The ball stays in its valley. But add heat. Make them jiggle faster. And a few atoms, just a few, start hitting hard enough. And when they do, when one carbon atom finally collides with one oxygen molecule with enough force to get over that barrier, they don't just react. They snap together. Feynman used that word deliberately. Snap. Not gently combine. Not gradually merge. Snap like a mousetrap going off. The carbon and oxygen slam into each other and lock. And when they lock, they release energy. A lot of energy. That energy flies outward. It hits the neighboring atoms. Makes them jiggle faster. Now 2 more atoms have enough energy to get over the barrier. They snap together. Release more energy. 4 atoms. 8. 16. 1 becomes 2. 2 becomes 4. 4 becomes 8. 8 becomes billions. In a fraction of a second. Feynman called this a terrible catastrophe. Not terribly as in bad. Terrible as in overwhelming. Unstoppable. A chain reaction so violent that it produces light and heat you can feel from across a room. That's fire. Now I want you to see this for yourself. If you have a match nearby, strike it. Right now. Hold it in front of you. Watch the flame. That tiny point of light. What you're seeing is billions of atoms snapping together every second. Carbon meeting oxygen. Barrier overcome. Energy released. Chain reaction sustained. Every flicker, every dance of that flame. Is a catastrophe happening at the atomic level too fast for your eyes to follow? Too small for your fingers to feel individually? But collectively, you feel the heat. you see the glow. That's what burning is. Not destruction. A cascade. A cascade of atoms snapping together, releasing energy as jiggling as motion. And that brings us to something most people get completely wrong. Heat is not a substance. It's not some invisible fluid that flows from hot things to cold things. That's what scientists believed for centuries. They called it caloric. They were wrong. Heat is motion. That's it. When something is hot, its atoms are jiggling faster. When something is cold, they're jiggling slower. Temperature is just a measure of how violently the atoms inside something are shaking. Which means fire is not a thing. You can't hold fire. You can't weigh it. You can't put it in a box and carry it home. Fire is a process, a self-sustaining chain reaction. Here's how the loop works. Heat makes atoms jiggle faster. Faster jiggling pushes more atoms over the energy barrier. Those atoms snap together, release more energy, more jiggling, more snapping, more energy. The reaction feeds itself, and it keeps going until you break the loop. Cool it down, the atoms slow below the barrier. Remove the fuel, nothing left to snap. Cut off the oxygen, no partner for carbon to grab. That's all firefighting is. Breaking the loop. Now here's something to sit with. Right now, inside your body, the same process is happening. Carbon from your last meal is combining with oxygen from your last breath. Releasing heat. Releasing energy. Keeping you at 37 degrees Celsius. But we'll get to that. And then, of course, you start to wonder, how did it get started? Well, it came from a tree. That cascade of snapping atoms, the carbon in the wood, was the fuel. So where did the carbon come from? Most people say the ground. The tree grew from the soil. It sucked up nutrients through its roots and built itself from the earth. That sounds right. It feels right. Everyone knows that. Everyone is wrong. Trees don't come from the ground. Trees come from the air. The bulk of a tree, the trunk, the branches, the wood you burn is carbon. And that carbon didn't come from the soil. It came from carbon dioxide. CO2. A gas floating around in the atmosphere at just 421 parts per million, 0.04% of the air. The tree pulled carbon out of thin air and built itself from it. Think about that. A 100-foot oak tree, thousands of pounds of wood, built from an invisible gas that makes up less than 0.5% of the atmosphere. Your chemistry teacher taught you photosynthesis as an equation. 6 CO2 plus 6 H2O yields C6H12O6 plus 6 O2. You memorized it. Maybe you even passed the test. But they never told you what it actually means. It means trees are built from thin air. The water comes from rain. The minerals from the soil, that's just ash. Burn a log and what's left? A tiny pile of powder. That's the only part that came from the ground. Everything else, the overwhelming majority of that tree, was pulled out of the air you're breathing right now. That tree built itself from the air you're breathing right now. Now, let me prove it to you. About 400 years ago, a man named Jan Baptist van Helmont did something beautifully simple. He took a pot of soil, weighed it carefully, planted a small willow tree. Then he watered it and waited. 5 years. When he came back, the tree had gained over 160 pounds. He weighed the soil again. It had barely changed. Almost the same weight as the day he started. 160 pounds of tree. Virtually no soil missing. So where did all that mass come from? Van Helmont concluded, water. He was close, but not quite right. Most of that mass came from carbon dioxide, an invisible gas that makes up just 421 parts per million of the atmosphere. Ling. 0.4%. The tree reached into the air and pulled carbon out of almost nothing. Van Helmont got the conclusion right. Trees don't come from the ground. But he got the mechanism wrong. And that's not a failure. That's science working exactly as it should. You measure. You conclude. And when someone measures better, the answer gets closer to the truth. So the tree pulls carbon from the air. But carbon dioxide is carbon and oxygen tightly bonded together. How is a tree smart enough to rip that apart? It's not. The tree doesn't do the hard work. The sun does. Sunlight photons traveling 93 million miles from the surface of a star slams into a leaf. And that energy is what breaks the bond. The sun rips CO2 apart. The tree keeps the carbon, uses it to build trunk, branch, leaves, roots. And the oxygen? The tree throws it away. Oxygen is waste. A terrible byproduct that the tree has no use for. It just dumps it into the atmosphere. The oxygen you just inhaled, a tree threw it away as waste. You're breathing plant garbage. Every breath you take is a tree's trash. Now here's the connection that changes everything. Remember the fire? Carbon and oxygen snapping together? Releasing energy as heat and light. Photosynthesis is the reverse of that process. Fire takes carbon and oxygen and snaps them together. Trees take carbon dioxide and rip them apart. Fire releases energy. Trees store energy. They're mirror images. Exact opposites. The same reaction running in two different directions. And the energy the tree is using to do this, to undo what fire does, is sunlight. The tree is using the sun's energy to pull atoms apart and hold them at a distance, storing potential energy in its own structure. Which means every log, every branch, every piece of wood you've ever burned is a battery, charged by the sun. The tree spent years, sometimes decades, pulling carbon out of the air, using sunlight to rip atoms apart and hold them at a distance. All that energy, all that effort, stored, locked inside, waiting. And when you strike a match, when you add just enough heat to push those atoms over the energy barrier, the carbon and oxygen snap back together. And the energy that was holding them apart, it escapes. As heat, as light, as fire. Fire is stored sunlight escaping. That's not a metaphor. That's not poetry. That is literally what's happening. The light and heat you feel from a campfire is the same energy that left the surface of the sun, traveled 93 million miles through empty space, hit a leaf, got captured, got stored, and is now being released. Right in front of you, a log burning in your fireplace is the sun shining again. Now try this. Look at the nearest light source right now. A lamp. A screen. A window. Whatever's closest. Trace the chain backwards. That light is powered by electricity. That electricity came from a power plant. If it's a coal plant, that coal was once a tree. A tree that captured sunlight millions of years ago. you're seeing ancient sunlight. If it's solar, you're seeing today's sunlight, converted. Even the food you ate this morning, plants that captured sunlight, or animals that ate plants that captured sunlight. Every source of energy you use traces back to a star. Let's stop here for a second, because I want to make sure you see the full picture of where we are. So far, fire is a chain reaction atoms snapping together faster than you can count. Heat is not a substance, it's atomic motion. Trees are not built from the ground, they're built from air. And fire, the thing you've watched your entire life, is stored sunlight escaping. But here's the thing. For over a century, the smartest people in Europe had fire completely wrong. In 1703, a German chemist named Georg Ernst Stahl proposed an idea. He said everything that could burn contained an invisible substance, a hidden element trapped inside. When something burned, that substance escaped. He called it phlogiston. It was elegant. It was intuitive. And for nearly 100 years, almost every serious chemist in Europe believed it. Phlogiston explained why wood lost weight when it burned the phlogiston was leaving. It explained why fire needed air. Air absorbed the escaping phlogiston. It seemed to explain everything. Until someone weighed a metal before and after burning it. Metals gain weight when they burn, not lose it. The exact opposite of what phlogiston predicted. Now here's where the story gets interesting. Because the scientists didn't abandon phlogiston, they didn't look at the evidence and say, "We were wrong." Instead, they did something far worse. They said phlogiston had negative weight, an invisible substance. That has no mass. That weighs less than nothing. That makes things heavier by leaving them. They changed the evidence to fit the theory. Instead of changing the theory to fit the evidence, and that right there, that impulse, is the most dangerous thing in science. More dangerous than ignorance. More dangerous than not knowing. The most dangerous thing is being so attached to your answer that you twist reality to keep it alive. It took one man with a very precise scale to destroy phlogiston forever. Antoine Lavoisier. Born in Paris, 1743. Wealthy, brilliant, and absolutely obsessed with one thing weighing. Lavoisier didn't trust theory. He didn't trust intuition. He didn't trust what made sense. He trusted his balance, his scale, the numbers. And he did something no one had thought to do properly. He burned things inside, sealed containers. Sealed. Nothing in, nothing out. Then he weighed everything before and after. Here's what he found. When something burns in a sealed container, the total weight doesn't change. Not by a gram. The mass before equals the mass after. Exactly. But the substance itself changed completely. The air inside the container lost weight. The burned material gained weight. Something from the air was joining the fuel, not escaping from it. Phlogiston, the invisible substance supposedly fleeing from burning material, didn't exist. Nothing was leaving. Something was arriving. Lavoisier identified that something. He called it oxygène, from the Greek oxygenes, meaning acid former. He was slightly wrong about the acid part. But the discovery was monumental. Fire isn't a substance escaping. Fire is oxygen from the air combining with fuel. That's it. That's what burning is. He published his findings in 1789 Traité élémentaire de chimie, the first modern chemistry textbook. The same year the French Revolution began. 5 years later, on May 8th, 1794, the revolution caught up with him. Lavoisier was arrested not for his science, but for his work as a tax collector. He was tried in the morning, convicted by afternoon, guillotined before sunset. The mathematician Joseph Louis Lagrange said the next day, "It took them only an instant to cut off his head. But France may not produce another such head in a century." Lavoisier didn't just identify oxygen. He showed us what fire actually is at a chemical level. He proved that nothing is created, nothing is destroyed, it only transforms. And it took humanity until the 1770s to figure that out. For hundreds of thousands of years, every campfire, every torch, every furnace, nobody really knew what was happening. Your chemistry teacher taught you combustion equations, balanced them on the board. But they never told you about the man who figured it out, or the century-long mistake he corrected, or the fact that it cost him his head. Let's take a breath. Here's where we are. Fire is a chain reaction, atoms snapping together. Heat is atomic motion. Trees are built from air. Fire is stored, sunlight escaping. Scientists got it wrong for 100 years with phlogiston. And Lavoisier, with nothing but a sealed jar and a very precise scale, proved that fire is oxygen combining with fuel. Now, a log in your fireplace stores sunlight from maybe 50 years ago. But what about millions of years ago? 300 million years ago, long before dinosaurs' Earth was covered in forest. Massive, dense, swampy forests. Trees taller than anything alive today. Ferns the size of buildings. All of them doing what trees do, pulling carbon from the air, storing sunlight in their structure. Then they died. Millions of years of trees, falling, piling up, getting buried under sediment, compressed, heated, squeezed for hundreds of millions of years. That's coal. Coal is ancient trees. Trees that captured sunlight 300 million years ago during the Carboniferous period. That sunlight is still in there. Locked in carbon bonds. Waiting. And when you burn coal, you're releasing sunlight from before dinosaurs existed. Oil? Ancient marine organisms, tiny plankton and algae that captured sunlight at the ocean's surface. Died. Sank. Got buried. Compressed for millions of years into liquid. Natural gas, same story. Different pressure. That's what climate change is at its most fundamental level. A mismatch of time scales. 300 million years of stored sunlight. Released in 200 years. The carbon that took epochs to bury is going back into the air in a geological blink. But let's go back to something more immediate. Something you can feel right now. If carbon and oxygen want to be together so badly, if the energy barrier is all that's keeping them apart, why doesn't everything just spontaneously catch fire? Because of something physicists call a metastable state. Remember the energy barrier from earlier? The ball sitting in a little valley on top of a hill? It's stable for now. It's not going anywhere. But it's not in the lowest position it could be. There's a deeper hole on the other side. If something nudges it, just barely tips it over the ridge, it rolls down and releases all that stored energy. That's a metastable state. Stable enough to sit there for centuries, but not truly stable. Just waiting. And the universe is full of them. The wood in your desk right now metastable, surrounded by oxygen. One match away from releasing decades of stored sunlight. The gasoline in your car metastable. One spark from an explosion. The natural gas piped into your kitchen metastable. The food in your stomach metastable. Wait. Food? Yes. The apple you ate this morning is sitting inside your body right now, surrounded by the oxygen you just inhaled. Carbon and oxygen inches apart, separated by nothing but a biological version of that energy barrier. An enzyme instead of a match. A controlled process instead of a catastrophe. But the chemistry? Exactly the same. Carbon combining with oxygen. Releasing energy. Producing CO2 and water. Your body is doing right now what a campfire does. Just slower. Just more controlled. Molecule by molecule instead of all at once. But before we go further, let's talk about that oxygen you're breathing. Where did it come from? Remember, the tree rips CO2 apart, keeps the carbon, throws away the oxygen. That oxygen, the gas you need to survive, is waste. Plant garbage. A byproduct that trees and algae have been dumping into the atmosphere for billions of years. Early Earth had almost no free oxygen. None. The atmosphere was carbon dioxide, methane, nitrogen toxic to anything alive today. Then photosynthetic organisms appeared. They started splitting CO2, keeping carbon, dumping oxygen. And that oxygen, it was poison. It destroyed almost everything it touched. The first great extinction on Earth wasn't caused by an asteroid or a volcano. It was caused by oxygen. But some organisms figured out how to use that poison. They evolved a way to combine oxygen with carbon, releasing the stored energy and running on it. That's you. That's what you are. A descendant of organisms that learned to breathe poison and turn it into power. Now see the full cycle. The sun sends energy to Earth. Plants capture it, ripping CO2 apart, storing carbon, dumping oxygen. You eat the plants. You breathe the oxygen. Inside your cells, carbon and oxygen combine, releasing the stored energy, exhaling CO2 back into the air. The plants take that CO2 and start again. Sun, plants, you, kudois, plants, you, a loop, powered by a star. Fire does this all at once. A campfire takes carbon and oxygen, snaps them together in seconds, releases all the stored sunlight in a burst of heat and light. Your cells do the exact same thing. Just slower. Just quieter. Just more carefully. You are, in a very real sense, a slow fire. Let me show you what that actually means. Layer 1. Your neuron. Right now, as you hear these words, your brain is firing electrical signals. Billions of them. Every thought. Every image. Every flicker of attention. Those signals are powered by glucose, a sugar your body broke down from the food you ate, combining with oxygen from your last breath. Carbon meeting oxygen. Energy released. Signal sent. Every thought you've ever had was powered by a tiny combustion reaction. The fact that you're understanding this sentence right now, that's fire. Controlled. Molecular. But fire. Layer 2. Your heat. Your body holds itself at 37 degrees Celsius. Not because something is heating you from the outside, because you are burning from the inside. Billions of cells, each running its own slow combustion carbon plus oxygen, releasing just enough heat to keep you at exactly the right temperature. Step outside on a freezing night. That warmth you feel under your coat, that's not insulation, creating heat. That's your body burning fuel. You are a furnace, a carefully regulated 37-degree furnace running 24 hours a day since the moment you were born. Layer 3. Eating. Every meal you eat is fuel. Literally. Not metaphorically. Not as an analogy. Your lunches stored sunlight plants that captured photons, or animals that ate plants that captured photons. You are a fire that feeds itself. A fire that walks to the kitchen, opens the fridge, and selects its own fuel. No campfire can do that. Layer 4. AMP. Inside every one of your cells, there's a molecule called adenosine triphosphate, ATP. It's the actual currency. The thing that carries the energy from combustion to wherever it's needed. Your muscles contracting? ATP. Your heart beating? ATP. Your brain firing those signals? ATP. Your body produces roughly its own weight in ATP every single day. Let that sink in. If you weigh 70 kilograms, your cells manufacture and recycle about 70 kilograms of ATP every 24 hours. All of it powered by the same reaction. Carbon, oxygen, snap, 4 layers, neuron, heat, fuel, ate. All of them the same chemistry as a campfire. The same reaction Feynman described. The same atoms snapping together. Just slower. Just smarter. Just wrapped in skin. Now, one last thing about fire itself. The part you actually see. That yellow glow in a candle flame? Those are tiny particles of carbon soot heated so intensely that they glow. They're incandescent. The same principle as an old light bulb filament. The carbon hasn't found oxygen yet. It's still searching. And while it searches, it glows. The blue part at the base, that's where combustion is complete. Carbon meets oxygen instantly. No have to have particles to glow. Just energy released so cleanly that the light shifts to blue. Every color in a flame is telling you a story. Yellow carbon still looking for oxygen. Blue carbon that already found it. The flame is a map of a chemical reaction, painted in light. And when the fire goes out, what's left? Ash. A tiny pile of powder. Remember, the carbon left is CO2. The hydrogen left as water vapor. The stored sunlight escaped as heat and light. Ash is just the minerals. The trace elements the tree pulled from the soil. The only part that was ever from the ground. Everything else, the overwhelming majority of that log, went back to the sky. Back to the air. Back into the cycle. So now you know what fire is. Do you? Let's see. Fire is not destruction. It's a chain reaction, atoms snapping together faster than you can count. Heat is not a substance flowing between objects. It's motion. Atomic motion. Jiggling. Trees are not built from the ground. They're built from the air, from an invisible gas that makes up 0.04% of the atmosphere. A 100-foot oak, pulled from almost nothing. And fire, the thing you've watched your entire life, is stored sunlight escaping. Energy that left the surface of a star traveled 93 million miles, got captured by a leaf, locked inside wood for decades, and released the moment you strike a match. A log burning in your fireplace is the sun shining again. For 100 years, the smartest chemists in Europe believed fire was an invisible substance escaping. Phlogiston. They were so attached to their answer that they invented negative weight rather than admit they were wrong. It took one man, Lavoisier, with a sealed jar and a very precise scale to prove that nothing was leaving. Something was arriving. And you. Right now. Sitting here. You are running on the same reaction. Carbon from your last meal meeting oxygen from your last breath. Neurons firing. Heat radiating. ATP cycling, 70 kilograms of it, every single day. You are a slow fire. A fire that feeds itself. A fire that walks to the kitchen and selects its own fuel. A fire that knows it's on fire. Feynman looked at a burning log and saw the sun. He saw the air. He saw photosynthesis running in reverse. He saw the entire history of energy from a star, to a leaf, to a flame, to your lungs. And he made you see it too. That's not comfort. That's not nostalgia. That's truth. And truth real, tested, why hid? Measured truth is the most beautiful thing humans have ever found. Now, everything I've told you today is sourced. The experiments, the history, the numbers. Links are in the description. If I got something wrong, tell me. Leave a comment. I will correct it. That's not weakness. That's how science works. That's how this channel works. And if this video changed how you see fire, if you now look at a candle and see stored sunlight, do something for me. Tonight, light a candle or a match. Just one. Watch it burn and tell someone near you that flame is the sun shining again. Watch their face, because physics isn't about memorizing equations. It's about seeing what was always there. And you just did. But here's something that should keep you up tonight. Every bond that held that wood together, every energy barrier those atoms had to overcome, every snap of carbon meeting oxygen, all of it governed by one force. The electromagnetic force. The same force that holds a magnet to your refrigerator. But what is that force? What's actually happening in the empty space between two magnets? You can feel it pushing. You can feel it pulling. Through thin air. Through nothing. What's between the magnets? Feynman was asked that exact question. And his answer will break your brain.